Now that we know the different types of partial problems from type 1, type 2, type 3 that we have looked so far, and even type 4 will cover eventually. So let's take a shot at the exam questions overall for the whole paper, and see how to identify and apply which type the problem belongs to, and also get a sense of what kind of problems are frequently appearing. So let's start with the winter 2019 paper. And again, like I discussed, the whole weightage of partial fraction is 8 marks. Typically you get 2 questions per paper for 4 marks each. So let's try to identify in the exam, if the problem comes, how to quickly apply this logic and see what type the problem belongs to. The whole partial fractions, not only the syllabus, but all the problems put together can be related to one of the 4 types. The first 3 types we already covered. Fourth type is pretty simple. We'll cover the improper fractions. I'll just give a quick walkthrough on this episode on this one, and we'll cover that in detail. But as long as you can pick up any partial fraction in the exam and rightly identify the type of the problems, which is one of these 4 types, that's 90% of the battle won, because that's the only substitution that you need to do, and rest of the computation for each of the partial fraction types is pretty simple. Okay, so let's try to apply whatever we have learned, and let's try to see where each type belongs to, or where each problem belongs to. So let's start with winter 2019, and I've written the question number and also the marks against each of the problems. Okay, so resolve into partial fraction. That's how you will get in the exam. So this is the first problem: 2x plus 3 the whole divided by x square minus 2x minus 3. Okay, if you see here, this appears to be quadratic to start with because of the power over here. But the first and foremost check we need to do is, for example, okay, let's say is this a partial proper fraction or an improper fraction. Further, we need to check the degree of the numerator and the denominator. Okay, so the degree of the numerator is 1, x to the power 1, and at the denominator the highest power of x is 2. So we have 1 here, we have 2 here, degree numerator and denominator. 1 is less than 2, that means numerator is less than denominator. So this becomes a proper fraction. Okay, so that means once we identify the proper fraction, we know that the proper fraction will belong to one of these 3 types: so type 1, type 2, type 3. This is a improper fraction, so this is a different type altogether. So proper fractions will have only 3 types: 1, 2, or 3. So the next job is to identify what kind of type this belongs to within the partial fractions or proper fractions. Okay, so this is proper fraction. I don't know what I said. Is it partial or proper? But there are 3 types in the proper fraction context. Okay, so now let's see whether it's type 1, type 2, or type 3. So the first and foremost check after checking the proper or improper fraction is to see if the denominator can be factorized in a simple way. And if you see, the given denominator appears to be quadratic, so it appears to be in this type. But let's first check whether it can be factorized. And if you see here, this problem I've solved in detail all these problems will be solved in detail in the next episodes. But this just to capture the essence of whether you're able to identify the types or not. So if you see this particular quadratic equation, this can be factorized as x minus 3 and I think x plus 1. So if you open up these brackets, which I've done in the next episode, you'll see it will match to this x square minus 2x minus 3. So whatever appears to be quadratic, or whatever is given as quadratic to begin with, we can successfully factorize them into linear factors like this. And these linear factors have degree 1 because they are linear in nature. And plus they are non-repeating. X minus 3 appears only once in the denominator if I substitute this back here, and x plus 1 also appears only once. So this is non-repeating linear. That means it belongs to type 1. So this problem belongs to type 1. Okay, let's go to the next problem. So next problem, if you see the denominator, it's in the same paper. I think the denominator, we have to just focus on the denominator because that's where this type categorization comes in play. So there are 2 factors. This factor is linear in nature. This factor is quadratic, just like the example above. But in this case, we were able to factorize this into 2 linear factors. Let's see whether we can factorize this particular term or this particular factor x square plus 4 into a linear factors. Looks like there is no identity by which we can factorize this. So x square plus 4 will remain quadratic. That means we cannot factorize it any further. And since we have a quadratic term or quadratic factor in the denominator which cannot be simplified into a linear, this will belong to type 3. So this is a type 3 problem. Okay, that's how you need to identify the problem. Once you identify, then it's like half the battle won. Let's go to the next paper. That is summer 2019. Okay, and I'm going to take this, copy this here also, so that it will be always an easy reference. Okay, let's see. Okay, all right, I've copied it here also. We'll copy it all along the way. Let me just paste it here also. Okay, and here also. Well, we cover all the problems. Okay, now we have it. Okay, so now summer 2019. So we have this problem in question 2C, resolve into partial fractions. So let's focus on the denominator. Okay, so looks like there are two factors. The first is linear. We don't have to break our head on that because the power of x is 1. The second is a quadratic factor. And like I said in the previous examples, over here also I missed to check. We also need to check whether the numerator and denominator, whether it's a proper or an improper fraction. So let's check that. The degree of the numerator is 1. The degree of the numerator is 1. The degree of the denominator, if you open up this bracket, we have the power 1 here, we have the power 2 here. But if you open up this bracket and combine this term, these degrees will add up. The denominator will have a degree of 3. 1 is less than 3, and hence it's a proper fraction. Although we have already come to the conclusion that it's type 3, like I said, in proper fractions, there are the first 3 types. So we already know that. But as a practice, I want to make sure that we always do this check first and then move to the factorization. So always check if it's a proper or improper. Okay. Over here also, let's do our proper improper check. So we have the numerator, we have the denominator. What is the numerator? X. That means x to the power 1. What is the denominator? Again, there's a 1 here and there's a 2 here. So if I open up the brackets and multiply it, the powers get added. 1 plus 2 is 3, just like the above example. Numerator is less than the denominator, and hence this is a proper fraction. Okay, that means it has to be belonging to one of the 3 types. Now let's focus on the factorization part. So we know that one factor, this particular factor is linear. This is quadratic. The question is, can this quadratic be simplified, or is it going to be the above problem where we cannot factorize it, and then hence we call this as type 3. So let's check that. So this x square minus 1 sounds like a square minus b square, which can be factorized as a plus b into a minus b. Again, like I said, I'm going to solve all these problems in the next few episodes, but this is kind of a quick run through. And if I do this factorization, that means I'm going to get something like x plus 1 into x minus 1. Okay, so what's going to happen, the denominator will have, let me write the denominator here. So what's going to happen is, there's already a linear factor here, x plus 1. Let me choose a different color for sake of simplicity. Let me choose green. Okay, there's already a given factor x plus 1. Okay, and this x square minus 1 this kind of splits into these 2 terms. Then we have x plus 1 and we have x minus 1. This is how it looks like. So what does it look like? All the factors are linear, so that's a good thing. Okay, so we have linear, all the factors are linear. That means this quadratic is ruled out. It's not going to be quadratic. Okay, and this is not improper. So this is going to be one of these 2 kind of types. But if you see this term and this term post factorization, this looks like repeating. This I can write as x plus 1 the whole square because it's repeating twice, and then I can write x minus 1. That means if I expand this, all are linear. If I kind of combine this looks like a repeating factor. Hence we have a type 2 repeating linear factors. This becomes type 2. That's how we need to identify. Okay, so now let's go to the next one. Okay, I think I might have to copy this once more. Okay, for this problem, that way it's easy. And let me switch the colors. Okay, so let's go with this. Okay, resolve into partial fractions. Now if you see here, let's do our first check of numerator and denominator. Let's do the check of numerator and denominator. The degree in the numerator is 4, x to the power 4. The degree in the denominator is 3, x to the power 3. Here the numerator, the degree of numerator is greater than the degree of denominator, and hence this is the example of improper fraction, type 4. Straight away, there is no need to worry about other fractions. This we have not covered, but just based on the degree, right? If the degree of the numerator is greater than or equal to either of them, okay, in this case it's greater, then straight away it belongs to type 4. So this is a type 4 problem here. So this is type 4. That's how we need to identify. Okay, let's move on. Okay, what is this? We are into winter 2018. So we have 2 factors at the bottom. Okay, so first factor is linear, and let's check the degree here first. To start with, I always kind of skip that step. Okay, the degree of the numerator is 2, the highest degree we have to take. And the degree of denominator, since it's a multiplication of two factors, once you open that up, once you open this multiplication, x is to the power of 1 and x square. We have a quadratic function here. So these powers will get added. So 1 plus 2, the powers will get added. 1 plus 2 will become 3 and 2 is less than 3 and hence it's a proper fraction. This is a proper fraction. When it's a proper fraction, that means we know that this is going to belong to one of these three types. Okay, so this is ruled out, so we don't have to worry about that. Okay, this is ruled out. Now let's see what's happening in the denominator. The first term, x to the power 1, let me just rewrite it. Let me start from the beginning. Okay, we know there's a proper function. Okay, the first term is linear, that's good. Okay, we have it linear. The second term is quadratic, x square plus 1. Okay, so we know it's quadratic. Okay, the next check we need to do is this quadratic factorizable? Can we factor this into two linear factors simply? Okay, and let's check out. So like how we did here. So looks like this is x square plus 1. In the previous example, it was x square minus 1. X square minus 1 you can write as a square minus b square and you can factorize. But there is no identity which kind of is of this format and which can be factorized. So we cannot break this down any further because there is no identity called as a square plus b square or something like that. So this cannot be factorized. So we have a quadratic that cannot be factorized, not factorized. Okay, we cannot be factorized. So whenever you get there, we don't have to worry. It's just straight quadratic, type 3 quadratic, because we cannot, whenever this is like this, basically not factorized. That's what it means, not factorized. Okay, so this is kind of a type 3 problem. Okay, quadratic. Now let's take this one. This one is pretty simple. We don't have to apply the new degree on the numerator and degree. If you see denominator, the degree of the numerator is 1, x to the power 1. And the degree of denominator, there are 3 x's, all have power of 1. Okay, if I multiply all of them together and all the powers get added, the degree of the denominator becomes combined 3. 1 is less than 3. Again, this is a proper fraction. Okay, and in terms of how are the factors looking in the denominator, you can see that each factor in the given problem is linear in nature. This is linear, this is linear, this is linear. So we don't have to do any manipulation. And once it is linear, we have to see which type it could be, whether non-repeating or repeating. We see that none of these factors, whether either it's x minus 4 or x plus 1 or x minus 1, none of these factors is repeating. Every factor is just appearing once, and hence this is a non-repeating linear factor. So this is a type 1. Okay, that's how we need to identify. Okay, now let's move to, okay, I think let me copy it again. So let's move to now the next paper, summer 2018. Okay, let's see what's happening here. Okay, summer 2018. Okay, so let's check the degree of the numerator and the degree of the denominator. Okay, the degree of the numerator is 2 over here. The degree of the denominator over here it's 1, over here it's 2. When you add the powers, 1 plus 2 is equal to 3 and 2 is less than 3, and hence it's a proper fraction. Okay, we have got that. Now let's check out the denominator and focus whether which type it belongs to. So we know that it's a proper fraction, so we know that it cannot be type 4. And by the way, just as for a quick fun fact, type 4 improper fraction in the last 4 years of 70 marks paper, right from winter 2019 all the way till whatever we have winter 2017, it has appeared only once. So that shows you the importance of the improper fraction, just once in this summer 2019 problem, and it has not appeared later or again yet. Okay, so just a quick note on that. Okay, so we are here. So let's see. So this is a proper fraction, so it cannot be type 4 improper fraction. So let's see which of the first 3 types it belongs to. So the first term is loose. It's almost linear in nature. X square minus 1. X square minus 1 we already seen here in this problem, x square minus 1, that it can be factorized with using this identity of a square minus b square, and hence x square minus 1 over here can be factorized, and this denominator can be written as x square minus 1 is x plus 1 and x minus 1 as shown above. This can be written like this. So now we have linear, we have linear, we have linear with all the degrees as 1, and is any of the terms repeating? This is x, this is x plus 1, this is x minus 1. So none of the terms are repeating. So after we factorize, we have a non-repeating linear factor, and hence this is again type 1. This is type 1 problem. Okay, let's check out this one. Okay, what's going on here? So if you see the denominator keeps repeating, so you don't have to worry much. You can easily identify what's happening here. So the numerator degree over here, let's check out first that the numerator has the degree of 1, and the denominator, if you open up this brackets, x is to the power 1 here in this factor. In this factor it's power 2, so 1 plus 2 is equal to 3, and 1 is less than 3, and hence this is also proper fraction. Okay, so we don't have to worry about the improper fraction in this example also. Okay, now let's check out what's happening with the denominator. Okay, the first term, I don't think we don't need to do anything. It's already linear in nature. It cannot be simplified any further. The second term is quadratic. So now we have to check whether this quadratic can be simplified and factorized into linear factors. But we already seen we can always factorize x square minus 1 because we have the identity of a square minus b square. We have seen that x square plus 1, even if you see the above problem over here, x square plus 1, this was not, we were not able to factorize this, so we have to leave it as it is in the quadratic format, and hence it was a type 3. And this problem is also not going to be any different because we cannot factorize, and whenever we have a quadratic which cannot factorize, it's a very simple choice. It's going to be type 3 because this is what quadratic means. It cannot be factorized. So this is going to be type 3 problem. Okay, let's check the last two problems from winter 2017. So we have a numerator here, we have denominator here. What's the degree of the numerator? It's x to the power 1. What's the degree of the denominator here? We have three terms, all are linear, 1, 1 and 1. That means if you open up the brackets, since each of these factors are being multiplied, if you open up the brackets, the powers are going to get added. So if you get added, you're going to get a cubic term. So if the power gets added, it's a cubic term. 1 is less than 3. It's again a proper fraction. Like I told you, improper fraction just appears once. And all these factors, if you see, they're straightforward linear in nature, just like one of the problems that we saw here. If you see here, the denominator, all the problems were already given as a linear factor. That's okay. And is anything non-repeating or repeating? Let's check that. X minus 1, x plus 1 and x plus 5. That means none of the factors are repeating. So this is going to be a non-repeating. So this is going to be a type 1 non-repeating linear factor. Last not but the least, let's check out what's going on here, and let me copy this again here. Okay, all right, let's see here. For the last problem, let's copy it here. Okay, so let's check the numerator and denominator as a quick check. That way now you'll have it hard lined in your memory that that's the first check you need to do, whether it's a proper or improper. The numerator degree is 2. The denominator over here is a multiplication of two factors. So let's add the powers. X is to the power 1 and x over here is 2. So 1 plus 2 is 3. 2 is less than 3. And again, this is going to be a proper fraction that we have got that. And at the bottom, let's see what can we do with the factors. Okay. So x minus 2, it's already simplified. It's linear in nature because the degree is 1. We cannot do anything about it. This is quadratic, x square plus 1. And we have seen that several times that x square plus 1 cannot be factorized. We have seen that in 2 or 3 instances. So cannot be factorized. So whenever you have a quadratic term and the denominator that cannot be factorized, it's straight away type 3. So that's how we need to identify which type it belongs to. And like I said, that's the most important step. Take the problem, go slow. You have only 4 types. If the degree is improper, then you don't have to worry about the first 3 types because the first 3 types are proper fractions and the degree of the numerator is greater than the denominator. It's going to be a type 4 problem which has appeared only once. I'm not saying that it may not appear again, but that's kind of a clue. And for the remaining 3 types, type 1, type 2, type 3 that we have covered in the previous episodes, it's going to be all proper partial fractions. And just check if the denominator can be factorized or it has to be quadratic, and then check if it can be factorized, that means it's not quadratic anymore, then check whether it's repeating or non-repeating and choose your type. So that's a sum of wrap up on the previous episode on how to identify the different types of problems within partial fractions. In the next few episodes, we'll take each type separately and solve all the problems and apply the learnings.